Welcome back everyone. So in the last few videos we have seen what are the different components incorporated within a landfill system, and in particular we have also seen in detail about a liner system. Now in a liner system, mainly the liner has to perform two functions. The first function that it has to perform is to collect the leachate that has formed within the landfill and you know um, do some provision for its drainage and removal. And the second function which the liner has to perform is to provide provide a barrier to the leachate which has a possibility of penetrating into the subsoils below. Okay, so in this video we will see in detail how what is a leachate collection and removal system and what are the main parts which are coming in it. So let's first see what a leachate is. Now leachate is a liquid formed from within the landfill waste. Okay, so depending upon the type of the waste, the type of leachate which has formed also varies. Now basically this leachate, there is a possibility that this leachate formed within the landfill can percolate into the subsoil below, and finally due to the transportation of leachate through the subsoil, it can join the aquifers and thereby pollute the water bodies ultimately. So basically when this leachate is percolating through the waste material, it will be picking up all the suspended and soluble materials that has originated from or which are products of the waste degradation along with it. Now the leachate has to be controlled within the landfill system itself for many reasons. Okay, so the first and foremost reason is to prevent the seepage out of the leachate from the sides as well as the base of the landfill. Now this is dependent upon the type of liner material that you have provided for the landfill system. So basically by exploiting the weaknesses of the liner system or the type of metrics the liner material possess, the leachate can seep out of the landfill, okay, either through the base of the landfill or through the sides. So that needs to be controlled. Now, the second reason is to prevent the liquid levels, these liquid levels rising to uncontrollable levels. Because if that happens, then it will pour and pour out, and then it will start polluting the ditches, drains, and the nearby water bodies. Then another thing which we have to make sure is to minimize the interaction between the leachate and the liner material. Okay, so our intention should be to make sure that there is no hydraulic head of leachate formed above the liner material, because if that happens then we will be tempting the liner material, and ultimately or over a period of time there is a chance that the leachate can percolate through the liner material, okay, due to some weaknesses formed in the liner material. So therefore we have to minimize the interaction between this leachate and liner material somehow. Okay, so that is where your leachate collection system comes into picture. That is, even before the interaction takes place, or to prevent that from happening, we have pipes embedded within the liner system to collect the leachate which has formed out of the landfill. And overall we have to ensure the stability of the landfill and to keep the leachate in control. Okay, so before designing a proper leachate collection and removal system, we need to assess the leachate quantity as well as quality, because only if we have sufficient information regarding the leachate, then only we will be able to design that leachate collection and removal system specific to the type of leachate. Okay, so let's first see how the leachate quality is assessed. Okay, now leachate quality is nothing but the composition of the leachate or the constituents present in the leachate. Now there are various factors which influence the constituents or the composition present in the leachate. Now most importantly, it is the type of waste. Okay, so the type of waste present in a landfill, it influences the composition of the leachate which is formed from within the waste material. Okay, and then the other factors which influence the waste leachate composition are the time, temperature, moisture, and available oxygen as well. Okay, and obviously the climatic conditions prevailing uh, in the site. Okay, that will also influence your leachate quality or composition. Okay, so before even during the planning stage of the landfill itself, we need to assess the leachate quality. Okay, and that early stage assessment is done so that we can identify whether the type of waste is hazardous or not. And then secondly, to choose a landfill design. Obviously by landfill design we are specifically talking about the leachate collection and drainage system, or the leachate collection and removal system that has to be accommodated within the liner system. Okay, so for that proper design we have to assess the leachate quality or composition. Then obviously leachate can be treated as any other wastewater. Okay, it is also a contaminated water which can be provided some treatments, okay, specific to the type of contaminants present in the leachate. So only if you assess the composition of the leachate, then only you will be able to find a suitable treatment plant, either outside the site, or based on the type of constituents present in the leachate, you can build a suitable treatment plant within the site itself. Okay, and lastly, we have to develop a list of chemicals for the groundwater monitoring program. Okay, so see, as part of the landfill monitoring, we'll have a groundwater monitoring system which will keep monitor whether any chemicals are found in the groundwater or not. Okay, so based on the leachate composition we will be able to understand what are the specific chemicals that can possibly come into your groundwater system. So you can specifically modify your monitoring system for those chemicals in particular. Okay, so leachate quality assessment can be done in a laboratory also. Suppose if you want to assess the leachate quality of a municipal solid waste, you can take a representative sample of, you can bring in a representative sample of the municipal solid waste to your laboratory and you can do the proper testing. Okay, and one such test is called as, toxicity characteristics leaching procedure, or TCLP test, which can be done on leachate to assess its quality or composition. But laboratory tests have a disadvantage, you know, because they don't represent the field data accurately, or they can never simulate the field conditions accurately, because in the field there are other factors which can influence your leachate composition, like temperature, the moisture, oxygen, and obviously with the increasing age of the landfill, the leachate composition will also change drastically. So these factors cannot be simulated in a laboratory. So ultimately whatever result you get from a laboratory cannot be treated as the final one. Okay, final leachate composition. Okay, so another way of assessing leachate quality before you construct a landfill is by collecting the actual leachate samples from old landfills. Okay, you have to visit some old landfill sites or waste dump sites, and from there you can collect the leachate, and that will be more that will give more representative results, okay, which can be applied to your new landfill design other than conducting laboratory test. Okay, laboratory test can also be conducted, but more accurate results or more representative results of the field would be can be assessed by collecting the leachate from an actual landfill site, like old landfill sites. Okay, and then assessing its composition. That is how we can do it. Okay, but there is a limitation that, whatever leachate you collect from the old landfill site and you test it for its composition, that composition is dependent on the age of that landfill. Okay, so you will have to do a certain number of tests, and you will have to see what is the change in leachate quality with respect to age of landfill and all. Okay, so this is how you normally assess the leachate quality, or you find the composition of the leachate. Now the next assessment to be done is of the leachate quantity. Okay, that is the amount of leachate which is produced from a particular waste fill, okay, inside the landfill system. Now basically leachate quantity, it's a liquid, so basically the quantity that is generated depends upon the amount of water which is infiltrating into your waste fill. Okay, and climatic weather conditions also influence the quantity of leachate generated, because the leachate generated during monsoon seasons will be different from the quantity of the leachate generated during the non-monsoon seasons. Okay, and we have seen that actually the land filling construction has two different phases. One is called as the active phase, and the second one is called as a closure and the post-closure phase. In the active phase of the landfill, what really happens is that the landfill is being constructed. Okay, so layer by layer the waste deposition is done, and then each day before the work is finished, a daily cover is provided to that waste deposited and compacted. So even though you provide a daily cover, but still if there is precipitation happening, or if there is a rainfall, if the active phase of the landfill, or the active construction of the landfill is taking place during the monsoon season, and all, obviously even with a daily cover you will not be able to prevent the water from infiltrating into your waste. Okay, so largely your precipitation influences the quantity of leachate produced. Okay, so there are actually equations to separately calculate the leachate quantities produced during the active phases as well as during the closure phase. Okay, so for the quantity of leachate during the active phase of the landfill, this the equation which can be used is that leachate volume is equal to the volume of precipitation plus the volume of the pore squeeze liquid, okay, minus the volume lost through evaporation minus the volume of water absorbed by the waste. Okay, so this equation will give you estimate of the leachate produced during the active phase of the landfill. Now, see, in order to understand the leachate produced during the closure phase or after the closure of the landfill, basically after the closure of the landfill means once the landfilling is done, or once the waste deposition is done up to the desired capacity and height of the landfill, then you will give or the final thing that you do to the landfill is to provide a final cover system to your landfill. Okay, and that will mark the end of the landfill construction. So that is the closure phase of the landfill. Okay, so once you provide with the final cover, then only that amount of water which can infiltrate through the final cover will mostly influence the amount of leachate produced. Okay, and there will be certain quantity of water lost by means of surface runoff also after providing the final cover. So once that final cover system is also provided to your landfill, then you can calculate the amount of leachate produced, okay, after closure of the landfill as volume of precipitation minus volume of surface runoff minus volume lost through evapotranspiration minus the volume of water absorbed by waste and intermediate soil covers. Okay, so this is how you can calculate the leachate quantity for the active phase as well as for the after closure phase of the landfill. Okay, now there is a thumb rule which you can adopt for the preliminary design of a landfill system. That is, if you want to estimate, approximately the leachate quantity during the preliminary design of the landfill, you can assume that, almost assuming that, there is no other runoff coming from outside areas to your landfill area, you can adopt this thumb rule. Okay, under that assumption, you can take 25 to 50 percentage of the precipitation from the active landfill area as the amount of leachate produced, and you can take 10 to 15 percentage of the precipitation from the covered areas. That is, once a final covered system is also provided, then you can assume that 10 to 15 percentage of the precipitation can be taken as the leachate quantity which will be produced from that landfill system. Okay, so this is a thumb rule which you can adopt for your preliminary design of landfill, under the assumption that there is no further runoff coming into your landfill from outside areas. Okay. Now, instead of using these equations, actually we have uh, computer simulated models that can, that will help us in estimating the leachate quantity. Okay, so one such model is called as a hydraulic evaluation of landfill performance, also abbreviated as HELP. This is one model which will help you in computing the leachate quantity generated. So we'll move on to leachate collection and removal system. Now, it is impossible to design any landfill without this leachate collection and removal system. So, irrespective of the type of landfill, whether it's non-hazardous or hazardous, this is a prerequisite. This leachate collection and removal system. Okay. Now, the basic the components which comes in a leachate collection and removal system are, you will have a filtration layer and then you will have a drainage layer, within which you will have provision for collecting the leachate. Okay, so there will be a protective filter layer over the drainage blanket if necessary to prevent the physical clogging of the material by retaining the fine grain material. Okay, now, either as explained before, you can go for natural materials or you can go for geosynthetic materials, which can serve the function of filtration. Okay. Now, after the filtration layer, you will have a drainage layer constructed of either natural granular material, that is gravel, or synthetic drainage materials such as geonet or geocomposites. Okay. So once the filtered water comes out of the filtration layer, a drainage layer will be provided through which the filtered water moves, and there will be perforated leachate collection pipes within this drainage blanket to collect the leachate and carry it to a sump or collection header pipe. Okay, so basically there will be many pipes installed within the drainage blanket, and all these pipes, the leachate which is filtered out of the filtration layer will be moving through the drainage layer and collected into these leachate collection pipes, and finally these pipes will be connected to one common header pipe, okay, or a sump. So finally this leachate collected through all these individual pipes will end up in a common sump or a collection header pipe. Then there should be a leachate monitoring point. Now leachate monitoring point will help you, periodically you can check the composition of the leachate or the quality of the leachate if you have a leachate monitoring point accommodated within the system. Then leachate collection sumps or header pipe system from where the leachate can be removed. So all the individual pipes which are installed within the drainage blanket will collect the leachate, and then those leachate from the pipes will be taken to a common sump or header pipe system. Okay, from there the leachate will be removed. Now this removed leachate will be taken out for different types of leachate managements, okay, which we will see in the coming slides. Now this figure here illustrates the longitudinal section of a liner system, okay, a total liner system. So a complete liner system comprises of two main parts, that is, it will comprise of a leachate collection and removal system, and then it will comprise of a liner system. Okay, so here the liner material which has been provided is a compacted clay liner as well as a geomembrane liner. So basically there is a composite liner system which is provided here. Okay, you have two barrier materials provided within this liner system. Now let's look at the leachate collection and removal part here. So this is This will be your sand layer, which will act as a filtration layer for the leachate. And then another geotextile filter is also provided here. So geotextile will also serve the same function as that of a sand. That is, it will also provide, serve the filtration function. So there is this geotextile provided beneath the sand layer, and then after the filtration layer you have the drainage layer. Okay, now the drainage layer is shown by these gravel material. So this here shows your gravel material. Okay, and then you can see that there is a perforated leachate collection pipes. Okay, so your leachate developed within this fill, filtered out of the filtration layer, and which comes into the drainage layer, will be collected onto this perforated leachate collection pipe. And in the plan, when you look at the plan, this thing would look like this. There will be like many small leachate collection pipes. Okay, like this. And the leachate from all these pipes will be collected to or will be pumped into a common header pipe, from where the leachate will be disposed of, either to treatment facilities or to other storage facilities. Okay, so here from the leachate will be leachate collection pipes are embedded within the drainage layer or the gravel layer, and then the leachate will enter these pipes, and there is a pump provided which will take this, which will pump the leachate collected into the common discharge pipe or header pipe. Okay, from there it will be taken out for other purposes. Now this is how a leachate collection and drainage system or removal system looks like. Now the section looks like this. Okay, so you have your collection layer, filtration layer, then geotextile filter, then after that your drainage layer, which is composed of gravel, and then you have your perforated leachate collection pipes. Okay, and below that you have your this thick black line is your geomembrane liner, and then after that, below that, you have your compacted clay liner. Okay. Now let's look at the design features and minimum standards to be maintained while designing a leachate collection and removal system. We have seen earlier that one of the reasons for controlling the leachate within landfill is to prevent any sort of leachate head from forming above the liner system, because if that is allowed to happen for a certain period of time, then the leachate will find its way through the liner material and ultimately into the subsoil below. Okay, so your leachate collection and removal system should be designed in such a way that you are allowing least interaction or minimal interaction between the leachate and the liner material. So this leachate head is which can be formed above the liner. It's actually a function of leachate generation, bottom slope, pipe spacing, and hydraulic conductivity of the drainage blanket. So the first, we will look into the first factor here, the basal shape. Now by the basal shape, see, if you look at the section of the landfill also, the liner system, it's not exactly flat at the bottom. It is provided at a certain slope. Okay, now that slope is essential so that there is a natural gravitational flow of the leachate collected in the individual pipes to the sump or the main header pipe. Okay, so in order to let that natural gravitational flow of leachate happen into the main header pipe, we have to give a minimum fall of 2% towards the leachate collection sump or the header pipe. And this gradient also promotes self-cleansing and reduces blockages in the leachate collection pipe. Okay, so the main intention of providing this slope is to allow the natural gravitational flow of the leachate from the individual pipes to the main sump or header pipe, and also through that natural flow there will be a cleansing happening uh, within the pipes. Okay, and so that there are no blockages occurring during this process of leachate collection. Then also we have to maintain a gradient towards the main leachate collection pipe at a minimum of 1%. Now, these are the specifications or standards to be followed when designing a drainage blanket. So, the minimum thickness of this drainage blanket, 500 mm. Okay, a thickness of 500 mm is to be maintained. And then, in some cases, it will go up to 900 mm as well. Then the minimum hydraulic conductivity of the drainage blanket should be 10 raised to minus 3 meter per second. Okay, and mostly if we are going for natural materials, then we'll choose gravel as the drainage blanket media. So this gravel should satisfy certain requirements, such as it should be rounded, pre-washed, non-calcareous stone, and then also the particle size should be compatible with the proposed geomembrane. See, this drainage blanket is going to come over your liner material, which is the geomembrane. Okay, and it should be such that it should not cause any harm to the geomembrane even during the construction of it. So the particle size should be compatible with the geomembrane, and then obviously we should assess the durability and the strength of this drainage blanket as such. As a proper layer, how is it going, how is the durability and mechanical strength going to be. Then since it's an aggregate that we are using here, there should be some standard aggregate test that should be done as which are specific to this particular design. So the next is regarding leachate drainage pipes. Now these leachate drainage pipes are like the most vulnerable to compressive strength failure, because even during construction also extreme care has to be taken to make sure that these pipes are not damaged during the construction process, because as we especially the horizontally laid pipes. Okay, and therefore for in the design of the leachate collection pipes, we should consider factors like the required capacity and the pipe spacing, then the pipe size and the maximum slope to be adopted, then the structural strength of the pipe. Okay, and these pipes should meet some minimum requirements, such as it should be a 200 dia perforated pipe, and made up of either high density polyethylene or polypropylene made with the best polymeric material, so that it has a durability of its own. And there should be a self-cleansing gradient. As I said, there should be a natural gravitational flow taking place within the pipe, and also a gradient such that there is no clogging within the pipe. And then the area of the pipe should be at least 0.01 meter square per meter length of the pipe. Then there should be enough crush strength for this pipes used as leachate drainage pipes, so that it can support the waste loading and all the operational practices that goes on during the construction of the landfill. Then these pipes should not be susceptible to any chemical attack, because the leachate composition will be composed of many chemicals, and the leachate drainage pipe material should be such that it is not susceptible, or it is not destroyed by any of this chemical attack. Now, one of the most common failures which is seen in this leachate collection and removal system is clogging. Now, when clogging happens within the filtration or drainage layer of the leachate collection and removal system, the entire efficiency of the system is decreased. Okay, so finally, the system will not serve the purpose for which it has to function. So clogging can happen due to many reasons. It can happen due to physical buildup of material within the pipes, okay, and that can be within the filtration layer or drainage layer. Now, other reasons of clogging include, like biological clogging. Biological clogging means it happens due to the growth of microorganisms. Okay, and the growth of microorganisms are promoted by the carbon nitrogen ratio in the leachate, and other factors which can influence their growth is the presence or absence of oxygen, the nutrient supply, etc. Okay, so Then other way of clogging is by chemical precipitation. Okay, so again that depends upon the pH, and usually when the pH exceeds 7, chemical precipitates are formed. Mostly it's calcium carbonates which are formed, and other than that there is magnesium carbonates and sulfur, which are formed. And these chemical precipitates or biological clogging is also a reason for the clogging of the entire leachate collection and drainage layer. Now, if we look at the leachate collection pipes alone, if we are not providing proper gradient for the pipes, okay, and then if no natural flow is happening within the pipes, then sedimentation can occur. Then if the pipe joins or at the intersections of these pipes, if those are not proper, then sedimentation can occur there. The flow will not happen properly. So this will all lead to clogging of the entire system. So once the clogging happens, your entire system's efficiency drastically reduces. Okay, so we have to um, uh, bring in some measures to prevent clogging of this leachate collection and removal system. Clogging in leachate collection and removal system. Now, to prevent clogging within the leachate collection and removal system, there can be various design measures that can be adopted. Especially when it comes to the leachate collection pipes, we can adopt a minimum diameter of 200 mm to facilitate its cleaning. Then, for the periodic cleaning of these pipes or for its inspections, we can provide access, at various at major pipe intersections or bends. Then also, though gradient is provided for the self cleaning of the pipes and the natural flow, but still for the complete cleaning of the leachate collection pipes, we can provide some valves or ports or such appurtenances, so that we can introduce cleaning solutions to these pipes for its complete removal of all such sediments within it. Okay, and it's also seen that most of the clogging happens, especially biological clogging or chemical clogging happens under aerobic conditions. Okay, so as much as possible we have to keep the system anaerobic. Hmm? Now it has been seen that under anaerobic condition there is a reduced clogging happening, and there will be less microbial aggregations and slimes produced under anaerobic conditions. Also the formation of carbonates, sulfates and iron oxides, which are a common cause of clogging, they are also much less prevalent under anaerobic conditions. Okay, compared to your aerobic conditions. So as much as possible we have to incorporate these pipe design features, as well as we have to keep the system anaerobic to reduce the clogging within the leachate collection and removal system. So lastly, we'll look into the leachate removal system. Leachate removal system basically is to collect the leachate from the individual leachate collection, perforated leachate collection pipes, which is provided within the drainage layer. Now you will collect the leachate from those pipes embedded within the drainage layer to either a sump or to a main header pipe. Okay. Now, if you're providing, so these are the various ways in which you can provide that. You can either provide a sump with a manhole extension, okay, rising vertically through the waste, and then it will join the final capping system. Okay, and the sump can be either prefabricated off-site or it can be made in situ as well. So basically, either you provide a sump with a vertical riser that finally is taken up to your final capping system. Okay, or you provide a sump. Second type is to provide a sump with a side slope riser. That is basically it will have a riser that will be taken up through the side slope of the landfill, and finally it will also penetrate the final capping system. Okay, and if we are talking about the main header pipe, then this header pipe that we are using for the removal system should be a gravity draining pipe. Okay, and it should also extend through and penetrate the liner system to a location beyond the landfill cell area. So you're taking it out of the entire landfill cell area. Okay, so we can use, see, we have talked about two types of sumps here, either a sump with a vertical riser or a sump with a side wall riser. Okay, so either you can use these separately, or you can use it in combination. And when you're using it in combination, actually you're facilitating easier maintenance here. Okay, so this is how, I mean, this is what a leachate removal system will comprise of, and this marks the end of your entire leachate collection and removal system, or you can even call it as leachate collection and drainage system. Okay, so thank you.